Hi everybody, welcome back to another series. Today I'm going to show you how to do the Taylor series, and before that I'm going to review some, let me sweep it up, I'm going to review derivative and factorial. Okay, well, so to some of you guys wondering why would I doing this to you, like why would I review this, because why don't just jump right ahead into Taylor series? Well, the reason is if you don't understand this, Taylor series is going to be very tough for you. So let's go ahead and review, okay? So what is 3 factorial? It will be 1 times 2 times 3 equal 6, okay? What is 0 factorial? Be careful. This is 1. I don't know why, but there's many mathematicians who explain better than me. But we gotta go with the fact that 0 factorial is 1. So 2 factorial is 1 times 2, 2, 4 factorial, 1 times 2, 3 times 4 equal 12, right? So what is n factorial? N factorial is 1 times 2 times all the way to n, okay? So what's the relationship between n factorial and n plus 1 factorial? Well, if you don't know, just try by plugging a number. So ask yourself this: what's the relationship between 3 factorial and 4 factorial? 3 factorial is 1 times 2 times 3, right? 4 factorial is 1 times 2 times 3 times 4, right? So you have 4 factorial over 3 factorial equal 1 times 2 times 3 times 4 over 1 times 2 times 3, just 4, okay? So 4 factorial over 3 factorial equal 4. Similarly, if you do this by yourself, you can see that 5 factorial, 4 factorial equal 5, 6 factorial over 5 factorial equals 6. So we have n plus 1 factorial over n factorial equal n plus 1. Okay, so n plus 1 factorial equal n factorial times n plus 1. Okay, now next part is I'm gonna review some derivative. So let's say I have a function x squared. What's the first derivative of this function? You do prime right here, you equal 2x, right? What is second derivative? This you would do, at first you do the first derivative, which is 2x, right? And then you do the next derivative would be 2, all right? So how about I have x to the power of n? Okay, the first derivative would be n times x, n minus 1, right? Second derivative would be n times n minus 1 times x. So n minus 1 would be n times n minus 1 times x minus 2. X to the power of n minus 2. Sorry. So instead of writing prime as the derivative, I'm going to write the number derivative up there. So xn to the power of 3. Which I'm going to do derivative 3 times. It will be, you do 2 times and do 1 more time, it would be n times n minus 1 times n minus 2 times x to the power n minus 3. Okay, so you see the pattern, right? So if I do it k time, it would be n times n minus 1 times n minus 2 times all the way to n minus k minus 1 times x to the power n minus k. Okay? Yeah, so in the next step, I'm going to explain the motivation behind the Taylor series, and we're going to go straight to business. Okay, thank you for your time. And if this review section does not help you, please go refer to other YouTube video about factorial and derivative for polynomials, especially for polynomials, so that we can proceed with your full understanding of the subject. Thank you so much, and I'll see you next time.